our stuff here. If you do have any questions on that stuff, just let me know. Okay, if I don't know, Mrs. Lemke will know. So, all right, so quadrilaterals and parallelograms. All right, first of all, what makes something a quadrilateral? 4 sides, right? That's all it is. Okay, that's all you need is 4 sides. So I've got a picture of this quadrilateral up here. All right, and it doesn't matter how it looks. It just has to be 4-sided. All right, now from a quadrilateral, we can break it down into different parts. One of the most basic things that we can break that down into is a parallelogram. Okay, if you know that you have a parallelogram, that means all 4 of these things down here are accurate. Both pairs of opposite sides are congruent. So first of all, we know that the opposite sides, you can't see that very well, opposite sides are parallel in a parallelogram. So all 4 of those are parallel. But we also know, because it is a parallelogram, that opposite sides are parallel, including top and bottom are congruent, including the top and bottom are also congruent. All right, but that's not where it stops, okay? Because we have this parallelogram, we know that opposite angles are congruent. So top right, bottom left are going to be congruent, and top left, bottom right are also going to be congruent. Okay, now that does not mean that all 4 of them are going to be congruent for every parallelogram, but it can be. All right, the other thing that we know, okay, say we don't have any of that stuff on there. We do know stuff about the diagonals. Now, think about this logically. We cannot say that that diagonal is equal to that diagonal. Okay, it's pretty obvious how I drew that this one is going to be longer than this one. Okay, it's possible in some parallelograms that they're equal, but we don't know that for all cases. All right, but what we do know is these diagonals cut each other in half. All right, so this part is congruent to this part. This part is congruent to that part. All right, that is something that we do know. All right, and then the last thing that we know for sure is that any pair of consecutive angles are supplementary. Supplementary means that it adds up to 180. So what that means for consecutive, that means this top left corner plus the bottom left corner is going to be 180. Top left, top right are going to be 180, and so on. All right, so we know opposite angles are the same, but we know consecutive angles are going to add up to 180. All right, from there, we can break it down into parts here, which you can see with both the rectangles and the rhombuses. So go ahead, I'll give you a little bit of time to write it down. Okay, as Kylie said back here, shorten it up however you can. All right, symbol for parallelogram would be that. Something similar to that, just a box that's tipped sideways. All right, looks like you guys are finished. From, as I said, for parallelograms, we can kind of break that down into more specific parallelograms. First one would be a rectangle. Main things that we need to know about a rectangle. First of all those properties we talked about on the last page still apply for a rectangle. So opposite sides are congruent. You guys already know that with a rectangle. Opposite angles are congruent. Well, they're all 90 degrees. You guys already know that stuff. So stuff like that always apply for these things. Okay, there's two extra things though. Okay, as I just said, number 2, all angles are right angles, which you guys already know. All right, and then the big one that gets forgotten for rectangles are the diagonals are congruent. Okay, so our diagonals through here are congruent. Now, logically, you guys would be able to figure that out. Okay, if I, for example, that this side is 3 and this side is 4, well, we can draw that diagonal in there. That would mean the diagonal would have to be 5, right? Due to Pythagorean theorem. And then if we did it for this other triangle, we do the same thing. We could find that this is also 5. All right, so that is always the case. The diagonals are always congruent for those. All right, for a rhombus, now even though that one looks like a diamond, okay, a rhombus does not always have 90-degree angles. All right, but there are pieces to it that we do know. Okay, like I said before, all parallelogram properties apply to this. Plus, all sides are congruent. So really, what that means here is say that I stretch this a little bit. That is obviously not just a square tipped on its side anymore, right? This would be more of a rhombus where all the sides are the same. Okay, if I see if I can move these diagonals the way they're supposed to be, probably not. All right, but what happens with the diagonals is the diagonals are always perpendicular to each other. All right, pretty close. You can kind of see it there. All right, so we've got 90-degree angles in the middle here. All right, the diagonals bisect the angles of that they came out of. So these two angles up here are going to be the same, just like these two angles on the left side are the same and all the way around. So then because of that, these 4 triangles are all going to be the same. Okay, and we can prove that by SAS. We could even do a proof to prove that that these would be the same by SSS and any of the rest of them. We could prove that by. All right, so those would be the properties of a rhombus. Okay, for a square, it's much simpler. I told you guys you're going to write a lot, and you're taking a college class, so suck it up, do it. Or at least a lot of you are taking a college class. Yes, you are. All right, a square, as it says up there, is just a combination of a rectangle and a rhombus. All right, where the biggest thing with the square is all the sides are the same and all the angles are 90 degrees. All right, but then number 3 there is accurate too. The diagonals form 4 congruent isosceles right triangles, which is not the case, not necessarily the case in any of the rest of them. All right, and then down below those are just 2 questions that they might ask you in the homework. So for that one right there in the middle, the diagonals of a certain parallelogram are not perpendicular. Which of the following could it be? Think about that as you're writing it there. All right, so what do we think for that question there in the middle? I drew some pictures up there, so you have something to look at. Which of the following are not perpendicular? Stetson, what do you think? Rectangle? Okay, if we drew in these diagonals here, okay, it's pretty obvious, especially the skinnier the rectangle it is, the more obvious that it's not going to be perpendicular for a rectangle. If you drew it in for a rhombus, okay, it's pretty obvious that those are going to be 90 degrees. And then for a square, because they're slanted, sometimes it looks like it, sometimes it doesn't, but it would be, they would be perpendicular in a square. All right, so for that one, it is just going to be A. This is something that they would throw at you in the homework. All right, they give you a situation, you have to tell which one it is, okay? Could it be more than one? Sure it could. Okay, so just be aware of that. Down below, given a parallelogram whose diagonals are congruent, which of the following must be true? Now, think about this. For a rectangle, are the diagonals the same? What do you think? Yes, the diagonals are going to be the same here. What about for this rhombus? No. All right, so this is out of here. For a square? Yeah, those are the same. All right, now, which of the following must be true? So we're down to these two, right? All four sides have the same length. Is that true? No, because for a rectangle, they don't have to be the same. So that one's gone. The diagonals are perpendicular bisectors of each other. The diagonals, we draw in these diagonals. Are they perpendicular to each other? No, but for a square, they could be, right? Okay, so that's where you have to think out all the different parts of it. So B is gone. All four angles of the parallelogram are right angles. That works for both of these, doesn't it? Okay, and that's the only way that, or it's the only one that would work for when the diagonals are congruent. Okay, so sometimes, like I did there, I drew out a picture so I could kind of look at it. I need to visually see it. Okay, I know some of the rest of you are very much the same way. All right, so don't be afraid to do that. Okay, and then to kind of mark up those pictures as you go. All right, trapezoid. Go ahead and copy it down, and we'll talk through it. Deal with it. Some of you don't have English today. We'll just make up for it. Plus, Newmiller's not here anyways, even if you did have English. Huh? Are they gonna be gone tomorrow? I don't know, to be honest. I don't think so. I don't think they're allowed to. So. Now, for that first one, sorry, I should have told you guys this first. For that first one, all this says, this is the word definition of it. What this is area equals 1/2 times the length of the altitude, better known as the height, times base 1 plus base 2. All right, that would be a way to shorten that thing up. I'm sorry, I didn't catch it soon enough. Now, properties of a trapezoid. A trapezoid is different. Okay, obviously, first of all, it still falls in here because it is a quadrilateral. It does have the 4 sides, but it is not a parallelogram, is it? Okay, for parallelogram, both sides need to be parallel. All right, for a trapezoid, you're only going to have one side that's parallel. The top and the bottom are normally the parallel sides. It could be tipped on its side, though. All right, so technically, if you have a really bad home plate drawn, right, where this side and that side, technically that would be an example that would work, but we do have 5 sides here, so it wouldn't be a trapezoid. But if there were 4 sides there, it could be tipped on its end, is what I'm getting at there. All right, so trapezoid though, most of the time we see a trapezoid as this blue one that I have here, all right, where opposite sides are also the same, all right, but technically this bottom one that I have down here in just yellow, all right, is also a trapezoid. If I tell you that the top is parallel to the bottom, that's all it takes for it to be a trapezoid, all right, as long as it is 4-sided. Okay, so one really outside of the area of a trapezoid, for all trapezoids, the only other thing that we can truly say about it is the median of a trapezoid is parallel to its bases. Now, what median means is if we were to cut this trapezoid in half, that would be the median, all right? And the median is parallel to the top and the bottom. The one thing that we can figure out, though, is say that our top is X and our bottom is Y. To find how long our median is, it is just the average of those two. So our median is always the top plus the bottom divided by 2. All right, and that is always the case for the median of a trapezoid. All right, now, say we do have an isosceles trapezoid, though, and that would be the blue one here. We do have some more consistent rules that do stay the same for that. First of all, the lower base angles are congruent. All right, so that would be this bottom one or both of the bottom ones. Okay, the other thing we know is the upper base angles are also congruent. So that'd be this top one and this one here. So those are congruent. The other thing that we know, I'm going to skip number 3, I'll come back to it. Number 4 any lower base angle is supplementary to any upper base angle. So if we add these two together on the left side, it's going to add up to 180. Okay. And that's always the case. Technically, they are correct. If we added the lower left and the top right, they would also have to add up to 180 in an isosceles trapezoid. Okay, the other thing that we know for sure is just in an isosceles trapezoid, the diagonals are the same. Okay, now one reason why I drew this one down here was if I drew in the diagonals for this one, that and that, this one is much longer than my first one that I drew in. Okay, so these four rules here only work when we have an isosceles trapezoid, and that just means that our side lengths are exactly the same here. Okay, any questions on the different properties for each one of these shapes? Really, the only extra thing that they would ask you would be something similar to both of these questions. So go ahead and copy them down, and then we'll do these problems. All right, so for the top one, the trapezoid has an area of 175 centimeters squared, a height of 10, and bases of x and 2x plus 8. Find x. So first thing we need the area equation for a trapezoid. So what is that again? A equals times base 1 plus base 2. All right, so from there, we just plug in what we know. So 175 goes in for A. The height is 10. And then we've got x plus 2x plus 8. And then we've just got one equation with just x as your variable. So we simplify this down. I'm going to leave the 175 over there. This turns into a 5 times 3x plus 8 when we combine like terms. All right, I'm going to divide the 5 over. You could have distributed it if you want. 175 divided by 5, I believe, is 35 equals 3x plus 8. Subtract the 8 over. We get 27. Divide by 3. Looks like x equals 9. All right, so after you get everything plugged in there, it's just an algebra problem, which most of the time you guys are really good at, okay? All right, for the bottom one, if EF is the median of the trapezoid, find X. What do we know about the median? X plus Y divided by 2. I don't have any Y's up there. top plus the bottom divided by 2. Yep. So 2x plus 2 plus 7x minus 2. So that's the top and the bottom divided by 2 has to equal the middle one. Okay. So what I would do here, I would get rid of the fraction. I'd multiply both sides by 2. So that would get the right side to equal 8x plus 2. And then I'd combine stuff on the left side to get it to a 9x because the 2's cancel there. And then we just subtract the 8x over. It looks like x has to equal 2. All right, so for this entire lesson, okay, these are going to be the most common questions that they're going to ask you. Okay, the only other ones that they'll really ask you would be some of these multiple choice things. Okay, these show up on the test every once in a while, but if you're going to learn, or if I'm going to ask you something out of this lesson, it's more likely to be one of these two than it would be the other stuff. Okay, so just a hint there. Okay, any questions? Quadrilaterals, parallelograms? We're good to go on to the next one? Get them both done? Logan's so excited up there. Yeah, I can tell. I know, I'm just happy you're awake, right? Yeah. All right, so lesson 34, we're gonna do some different stuff here. Just copy down the title. Do not copy down the problems because computers are dumb sometimes. And that's not how this is going to look in your on a test or in your homework or anything like that. All right, now how these problems are going to look in homework and on tests it's going to look more like this. We're going to have the 4 up above it. We're going to have the x equals 2 below it. And then you're going to have this x cubed there. Okay, so do not write it like how it's written in this on the board there. Okay, write it like how I have it down below. So if you want to copy the next one, kind of the same concept. X equals 2 on the bottom, 4 on the top. And then we've got a 2 all by itself. All right, any idea what that kind of E shape looks, or what that means? Has anybody seen it before? If you've done anything in Excel, Microsoft Excel, you've seen that. Okay, what that stands for is that stands for the sum of everything that you're doing. So in Excel, they have this as a function where you just hit that button and then it'll add up either everything above it or everything to the left of it, and you can kind of program it how you need to. All right, but what this stands for math-wise is the bottom tells us our starting point, the top tells us our ending point. And what we're going to do with that is we're going to plug it into our function. So what this means is we're going to start with 2, and we're going to put a 2 in wherever we see an x. So we start with the 2, we get 2 cubed. And then we always do it by whole numbers, so you don't have to worry about the decimals or anything like that. Then we'll put in a 3 and cube it. And then we'll go to a 4 and also cube it. We started at the 2 because that's what it is on the bottom. We ended at a 4 because that's what our top number is. Okay, now these two numbers can be anything at all. Okay, just so happens that both of them are 2 and 4 here. That doesn't mean anything. Okay, so then from here you just simplify this. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Add those together, I believe you get 99. And that's what your answer would be for this. Okay, so The math part isn't hard, okay? It's just realizing what this is talking about here, okay? Now, every single time for the numbers that we plug in, we always plug it in for an x, okay? And then we write down what comes out of it, all right? Well, this one doesn't have an x here, right? So what do? We plug in a 2 where the x is, and what pops out is a 2. Then we plug in a 3 wherever we see an x, and what comes out is a 2. We don't have an x there, so the value is not going to change. We plug in a 4 where we see the x, and what comes out is a 2. All right, so just because there's no x there does not mean that you can't do it. That's just this 2 is going to be what comes out of it, no matter how many times that we plug numbers in. So 2, 3, and 4 give us 2's for each one of those. We add those together. 6. Okay. All right. So just because there's not an x here doesn't mean that we can't have something come out. So this is more like, this tells you what your domain is, what you're plugging into the problem. What comes out of it is your range. Okay. Let's take it up a step here. All right, so we've got the summation from g equals 0 to 6 of 2 to the g power over g minus 3. All right, so this one's going to be a little bit more complicated here. It's okay. All right, first of all, we're going to plug in a 0 here. So we get 2 to the 0 power over 0 minus 3. And then we're going to add to that 2 to the first power over 1 minus 3. And we're going to keep doing that until we get all the way to 6. All right, so if you plug in 0 through 6 there, you should get something that looks like that up there. And then we just have to simplify. All right, so 2 to the 0 power is 1 over -3, so we got a -1/3 there. 2 over -2, well, that would end up being a -1. We'll deal with that in a little bit. 2 squared would be a 4 over -1. 2 cubed would be an 8 over 0. What is this going to mean right here? So then technically we could stop, because can you add an undefined value to everything else? No. So what do you think our answer is going to be here? It's going to be no solution. Okay. So some of you probably saw that almost immediately. Others, we got to get through and actually do the work to be able to see that. Okay. Say, for example, though, that this one wasn't here. You would just add all of those pieces together to get your final answer. All right. So summations. You start with the bottom number. You plug it in. You go all the way up to the top number. And then at the end, you add them all together. All right. Yes, there's a button in the calculator, Maxwell. Where's it at? Yep, the answer would be no solution. Did you find the button on the calculator? Yeah, I don't remember where it's at, but yep. Where's it at? Number 10? Oh yeah, there it is. Yep. Yep. In the yellow calculators, okay, or any of the graphing calculators, if you hit the math button and you go down to number 10, probably for most of you, it says summation, and then it's got the E there. All right. Kayla, did you find yours? You don't think it works? Why? Okay, I haven't tested it. I don't know. It's just for these calculators. I will have to check it out with yours. Huh? Yeah, it says math. So I will check that out for yours and Kayla's and Abby's. I don't know. I haven't looked yet, even though I have one. Okay, so here. Let me plug it in up front, and then I'll show you. Okay. Yeah, that's it. All right. So all right. So for those of you with the calculator, okay, if you go to math and you go all the way down to 10 here, okay, we have this summation button. Okay, you hit that, and then where the boxes are, you just have to fill those in. Okay. For this first box, we just need a variable. So if you look right next to your alpha key, that's an X. All right. So instead of putting the G's in there like that one has, you can just put any variable in there. Okay. And then we have to go from 0 to 6. And then you just have to type in the equation. So it'd be 2 raised to the x power divided by x minus 3. And that x minus 3 should be in parentheses. All right, so then if we hit enter here, it's going to give us, so we have to divide by 0 there, which would tell us that it's no solution. Okay, so that's how it would look. You could type in that whole thing there. Now, the math part of it, is it super difficult? No. Okay, so it's not bad to do it either way, but yes, there is a button on the calculator to be able to do that one. Okay, questions at all? Riley, Kayla figured it out. Okay, so if nothing else, Kayla can teach me in a little bit where it's at, and then I can show you. All right, you found it? Okay. All right, so from there, if you have any questions with that stuff, you let me know. All right, but from there, we need to find a line of best fit here. All right, so go ahead and copy this down. No, you don't want to copy it down? I'm done copying today. You don't have a graph. You can't make a little T on your paper, huh? Really? It's just that impossible. All right, so do the best you can with getting that graph on there. I know it's not very easy. And then today what we're going to do is we are not going to find the exact equation. Okay, there is a way when we know a whole bunch of data points of finding exactly what the equation would be. That's going to be a different day. All right. But what we are going to do is we're going to be able to find the estimated one. You can just sit behind Max. All right. So we've got some points there. All right. Now, for a line of best fits, it's just a guess, right? Okay, we're going to throw in a line there that's going to be an estimate of what we think the average might be. Now, what do you think? Maybe something like that? Okay, we should make it straight. But what I would tell you to do is be very careful with your line. It is your estimate. All right, I would make sure that we have some kind of points to kind of work off of here. Let's see this down here. All right, and what I did with my line, first of all, it's got to be the average of all the line or all of the points there. Pretty close. It might be able to come down a little bit, but it's pretty close to what it is. Okay, now what I did with my line was I made sure that I ran it through this point here, and I ran it through this point right here. Okay, be smart with your line of best fit. All right, we are just finding an estimated line of best fit. For that, you have to have at least 2 points. Okay, so my 2 points are, see, this point is -6, 8, and this point over here, this point here is 6, -5. All right, so we need to find what of that line. First of all, we need to find the slope. All right, you got the equation is y2 minus y1 over x2 minus x1. We just plug in our y values. So 8 minus -5 over -6 minus 6. We get a slope of 13 over -12. Not the nicest slope in the world, but it'll work. All right. Now from there, we just have to make an equation. What is the easiest way, or what's the easiest form to put this into? You remember? What's that? Point slope is the easiest. Okay, that's where you just need one of your points and you need a slope. Doesn't matter which point. No, you can use either one. And then you throw it into the equation. Y minus y1 equals m times x minus x1. All right, so I'm going to plug in this top one. Y minus 8 equals -13 over 12 times x plus 6. And that is our equation for the line that we drew in there. All right, now for this, very important that you tell me your 2 points that you're using that's on your line, okay? On the test, you're gonna have a graph very similar to this up here. You just have to, show me your line, and then you have to show me which 2 points you're using, okay? Does it really matter which 2 points you use? No. If there's lots of points that work, you can use any 2 of them, all right? And then you come up with any equation you want. This is just the fastest one to get the answer for. All right, questions there? All right, last page, and then we're done. Find 2 functions, f and g, such that f of g of x equals the square root of 2x plus 1. So what this is asking us is we want to figure out what f of x equals and what g of x equals to get this final answer here, okay? Now there are different ways to get this answer, okay? And there's different things that you could put in for each one of these to end up with this thing, all right? But what I would say for this is we know that our answer has to be here, all right? If I start with the square root over in the f function, say I put that as an x, what do I have to plug in for x to make it be equal to this right here? 2x plus 1, that has to be your g function. Okay, so what I would start with is I would look at the biggest, the furthest out part of this function, and that's my outside one, and then figure out what has to go in there to make it equal the answer to give us our other function, okay? And remember that how this is written, f of g of x, that means we're going to plug the g function into the f function, okay? Now, this is one answer of, there's an infinite amount of answers for this, okay? So this is one of those that if you think your answer is right, but it doesn't match the answer key, let me know and I'll take a look at it, okay? All right, down below, we are given what g of x equals, and we're told what the final thing needs to look like. F of g of x equals 1 over x squared plus 1. We are asked to find f of x. What does f of x have to equal? Max says 1 over x. If we plug g of x in here for an x, we would end up with that, wouldn't we? Okay, so we're kind of, this is kind of like pulling a puzzle apart, all right? We're given what the final picture is going to look like. How are we going to get there? Okay, so that's what you're doing with those. These are a little bit harder to see just because it's more of a visual thing, and it's not something that we practice very often. So it's good to get a little practice with this. All right, questions for me? All right, like normal, lesson 33 and 34, 25 questions. Okay, I told you guys which ones you should probably practice due to what was very commonly wrong on the first page of the test. All right, and then no quiz on Monday because we had a test on Tuesday. All right, but you will have a quiz on lesson 33 on not Wednesday because we don't have school, but on Thursday. All right, I believe we would have this class on Thursday. All right, questions for me? All right. Not right now. Do you want a test next week? Okay, I didn't think so. I will probably push it back until the next week. All right.
Find that thingy that you were talking about.
Okay, give me just a second. Let me hang up on Connor. I'm going to let you go.
Okay.